Hello, everyone. Welcome to this Causal ML research panel at the MSR Research Summit. I'm Adith. I'm a researcher in the Redmond lab. I study causal reasoning and reinforcement learning with applications in user interactive systems. I'm most excited by the potential for counterfactual reasoning. For those who have read the Book of Why, this is the rung 3 counterfactuals in enabling new high-stakes RL applications. MSR has a long history of research in causality, decision-making, and machine learning, right from David Heckerman's work in the late 80s and early 90s during the early days of MSR, Chris Meek's influential work on causal explanations, Max Chickering's work on causal discovery and learning in Bayesian nets, and almost 3 decades later, causal ML research is going strong and powering many impactful applications today. So this panel should give a few glimpses of the kinds of research that's happening across MSR labs. So we will not attempt to give a comprehensive picture of everything that's going on, but we will hear diverse perspectives from lab members in Cambridge, UK, Beijing, China, and Redmond, USA. First, a quick round of introductions. Let's go around the room in alphabetical order. Daniel, do you please want to introduce yourself and what you work on?
Thanks, Adith. My name is Daniel McDuff, and I work in the HUE group at MSR, which stands for Human Understanding and Empathy, and we focus on understanding human behavior in different forms through measurement of physiology as well as observable measurement of expression. And I'm very interested in causal reasoning for the ability to build models that better generalize to observations that maybe haven't been seen in the past. And this is something that's often very challenging when considering human behavior. There may be behaviors that you've never seen before or that are very rare. And also the interpretability that those models offer, the ability to be able to explain why decisions were made by a model and understand what the model has learned from large sets of data.
Next, Javier, do you want to please tell us about your background and your work?
Hello, everyone, and thanks for the invitation to this panel. My name is Javier González. I'm a researcher in the Microsoft Research Lab here in Cambridge in the UK. I'm part of the Health Intelligence Group, where our goal is to build robust and trustworthy machine learning methods to improve the way we do medicine. I'm particularly interested in causal inference as a way to encode mechanistic understanding of biological processes of interest or medical knowledge that we have about our problems in the models that we use to solve prediction problems or problems in which we are interested in computing some specific causal quantity. Obviously, this involves a few things. Reasoning about counterfactuals is one of them, making predictions in domains in which we haven't observed data, in which we have trained our models. And I'm particularly interested as well in how we can quantify the uncertainty of all these quantities, whether they are predictions or causal quantities. So we can do data fusion and all sort of things with the data that we have.
And finally, Justin, do you want to tell us what your journey to MSR was like and what do you work on?
Yeah. So hello. So I'm a researcher in the data analytics research team in the Microsoft Research Asia. I'm currently conducting the research on auto insights, aims at automatically discovering interesting and meaningful data patterns and to facilitate the exploratory or predictive data analysis. But I'm also very recently focusing on conducting research on causality and explainable AI to provide deeper insights, provide the explanations and action suggestions to bridge the gap towards the automatic and robust decision making.
Yeah, so thanks everyone for joining this panel. Maybe the most top of the mind question I have is, what is the biggest opportunity you see for causal ML research to impact the world? What is your vision of the future and how can causal research enable it? I'm particularly curious to hear Javier's thoughts on this first.
Thank you very much, Adith. So I I think I'm very fortunate of being in a team in which we use Causal ML every day. So the world of healthcare gives us a lot of opportunities of impact for this type of techniques. So we can think about some of them. For instance, the estimation of individual treatment effects and how that's translate in counterfactuals that can inform what type of treatment we should be giving to patients. Or when we think about counterfactuals, how we can do data augmentation so we can improve the way we do image classification, or the way we can make predictions of disease given some biomarkers of patients in populations in which the models that we are training haven't seen the data. So we see causal ML everywhere in the healthcare domain, and it's an exciting field where we can apply this type of techniques in different ways, in ways in which causal inference can help standard machine learning methods that we were using to do predictions, and also in the way machine learning can inform and can help standard or causal inference in the way we compute causal quantities. I see the two directions very relevant in the field.
And Justin, I know that offline when we were exchanging emails, you really sketched out a very compelling vision for the future of data analytics. Do you want to share?
Yeah, sure. So from the very high level, in order to make the causal machine learning for analytics, data analytics applicable, I think there are three major challenges. The first, I think, first of all, is the democratizing causal concept into the domain of business intelligence or data analytics. And I think the second one is how to acquire the appropriate causal knowledge. So in different business domains, people have different domain knowledge, but most of them are, I think, stored in mind in a partial way or pieces. How to leverage the data-driven approach combined with the domain knowledge to come up with a reasonable causal knowledge is, I think, the second challenge. And the last thing I think is also about the caveat of adopting or using the causality. So from my point of view, causality is also a type of way to representing the assumptions. So you can use causal knowledge to conduct further analysis towards some conclusion, but you should also always keep in mind that all these conclusions are built upon some assumptions, and there might be some risks if you fully trust that. Yeah, that's my point of view. Thank you.
I think Justin addressed a few of the opportunities, but also the challenges in the applying causality in data analytics. I'm curious, Daniel, what are the opportunities and the challenges you are foreseeing in some of the causal ML research that you're doing?
Yeah, I think there's a lot of opportunities in the human-computer interaction domain generally, in building models that can explain why decisions were made and help. And that, I think that's essential for having algorithms with humans in the loop. When you have humans interacting with systems, being able to do causal inference and modeling, I think is really critical, and nowhere more so than in safety critical situations, whether it's humans interacting with self-driving vehicles or robots. That's where I think there's really big potential to make those systems much more practical and safer, importantly.
Do you want to plug the CausalCity work that you've contributed to? Because it seems like
absolutely.
Yeah.
So one thing that we're working on is using high fidelity simulations to enable some of this modeling and take a lot of causal structure learning, which has been done on relatively sort of contrived and simple simulation scenarios into scenarios that are much more similar to the ones that we have in real life, like self-driving vehicles. So we've developed a simulated environment where we can control causal relationships very carefully, and that allows us to generate data sets to test for instance, causal structure learning models, and also do sort of counterfactual reasoning with the combination of computer vision and inferring, doing perception as well as causal inference.
I guess it's alluding to, so I'm sensing a trend now in the responses where we are switching from the opportunities to the challenges and what we can build today to get after those challenges. I'm actually quite curious to know what makes research in causal ML methods hard? Like, why is this challenging and why is now the time to go after it? Daniel, let's go in reverse order.
Sure. Yeah. To build on what I just talked about, I think what has made it hard in, for instance, the computer vision domain in the past is that building data sets where you have causal relationships has been very challenging. You often have a very long tail of observations of rare events, and you just don't have the ability to build strong data sets with rich causal structure, because those images might be gathered more opportunistically, scraped from the internet or different locations. So I think simulation really offers a lot of opportunities for us to go much further beyond that, and we've only recently had the ability to build these high fidelity simulations as well as generate the amounts of data that we really need to make them useful. So that's one thing, and what we're trying to do with the CausalCity work is to try to make that more accessible to other people as well, so to make it an open platform that people can generate their own data sets with different causal relationships.
How about Javier? Do you also see the role, is it powerful simulators that are unblocking these individual treatment effect style causal quantities that we might go after in health?
Yeah, I think it's a bit harder in the health domain to think about simulators of a patient, and I think one of the harder things that we face when trying to solve problems related with causal inference in the healthcare domain is that we are never sure about whether we are making the right assumptions or not, because there is this endless loop of trying to model medical or a biological phenomenon, trying to learn from the modeling that we have done, collecting more data, and trying to redefine the hypothesis that we are making. In some cases, you can use simulators, but when we think about the effects of a drug in the response of a patient, we are working on a very high level of granularity of how the biological processes are happening. So the way of operating by writing a causal graph sometimes is very hard. Sometimes we know a part of the graph, we need to discover other part of the graph in order to make sure that we are making the right assumptions, are computing the right quantities. And obviously also the scarcity of data and the different modalities of data that we have to combine, the different confounding effects that we may have in the different type of data. That's also very, very challenging. That builds on top of what I said.
Yeah, this loop that you described between constantly refining assumptions as it touches the real world and go back and redo it. It also ties to something Justin just mentioned earlier, which is that causality is really, you can think of it as a way to express domain knowledge and to be more precise about our assumptions and be able to blame assign which assumptions might be wrong and go back and fix it. And I'm curious, Justin, in data analytics, are we making progress? Is now the right time to be building these BI tools to enable easier iterations through this really hard loop?
I think the recent years is a very good time. It's a very good opportunity. So there's an interesting story here. So I will start from the explainable data analytics. So it is basically about the scenarios where users pose and seek answers to the why question. So when users see some bar chart, see some sales marketing data and want to say why this happens. This is a typical scenario in the BI domain, business intelligence. And actually, there have been some product tools aimed to answer such a kind of wide question, such as the Tabula's explain data or Microsoft Power BI's explain increase decrease. However, these approaches currently are association. The approaches are association, but not causal. So therefore, sometimes there will be some funny results since users somewhat have the intention to seek for the causal effect answers. So in my opinion, so acquiring causal knowledge is the primary step before conducting such kind of data analysis. But in the BI domain, there are two challenges. The first is many data collected in the BI domain are causally insufficient. So the data collections, they may not be sufficient. So there are a lot of the latent confounders there. And the second thing is many data sets are stored in the database in terms of multiple tables, subtables. And when they join together, so there are some deterministic relationships among the variables. So they're no longer stochastic but deterministic. As a result, the faithfulness assumption no longer hold in many cases. So in summary, when we want to adopt the classical causal structural learning algorithms, just a reminder that the causal sufficiency, the faithfulness assumptions usually often no longer hold. So we have to come up with some novel ideas to address those challenges. I think this is an interesting opportunity and also challenges for us to conduct causal machine learning for data analytics. Yeah.
Maybe like thinking ahead, I'm also curious, like we have heard like three very compelling applications, right? Like in healthcare, in human interaction, in business analytics. I'm curious if someone wanted to contribute to these research directions, to really go like do a deep dive on causal ML, right? Like how can we get some tips from the experts on causal ML on how can one contribute to this direction? Maybe we'll start with Daniel.
Yeah, I mean, one practical way is we're, as I mentioned, trying to enable people to be able to work with the types of simulators that we're developing to build data sets with different types of causal relationships. And it was interesting in what Justin said about, multiple modalities. That's something where I think there's huge scope for kind of investigation, because as you increase the number of dimensions in your data, you're going to introduce many potential confounders. And so these simulators, they have a lot of modalities or a lot of dimensions to them in terms of what can be controlled, whether it's weather conditions in the environment or the behaviors of the vehicles or pedestrians or all of these types of things, and so there's any number of potential ways that you could use that to generate novel data sets. So that's one very practical way, but I think as a whole we're really just scratching the surface of creating, I think, models that can learn, that really can learn the structure, and then think about the downstream applications that then enables in the types of applications that we're working in, which is kind of looking at modeling and understanding human behavior in environments and how people interact with machines. So I think there's just a real opportunity here to develop new models that have not just learn simple relationships between edges in a graph, for instance, but can make those much more interpretable for people, and also just enable more people in the community to kind of leverage the types of tools that we're trying to build here.
So if I'm hearing correctly, that means I shouldn't be thinking of this as we are just getting data sets out of these rich simulations, and then we can apply end-to-end deep learning or deep reinforcement learning or something like that and just say, go, it's done. It's like you actually believe that there is also causality in the methods that are being applied to these data sets that can extract the structure and reason about the world. I'm curious, like Javier, like just now in Daniel's response, like the question of interpretable and explainable solutions also came up, and I'm sure that the healthcare domain must have many instances of that need. Speaking to the broader question also of how does one contribute to this very gnarly problem of learning for health?
Yeah, absolutely. So in the health domain, you need your algorithms to be completely transparent. Because if you want your algorithms to be applied, they will need to be approved by some entity, and it should be completely clear why they are making certain predictions and or making certain decisions. So yeah, the point of having interpretable models is key in the health domain. A way to start building that, and that builds on top of the question of how to collaborate to do causal ML in the healthcare domain. I think something that is key is to have a very open attitude towards sitting down with the expert in the health problem that you want to solve, and to develop a communication strategy that makes you to understand the details of the problems and not be afraid of discussing that over and over until you get a common understanding. And for instance, something that I have experienced in the past is that using causal graphs to develop a common understanding and a common language with someone who is a biologist, someone who is a doctor, who may not be used to think in terms of causal inference methods per se, but people who have a very deep understanding of the problem, thinking about causal inference as drawing a graph and start reasoning and depurating the graph in the previous steps that I was showing before. As you collect more data and you depurate your hypothesis, is key to get to a point where you can have a successful algorithm that you can interpret, that everyone is happy with. I would say that's key in all the collaborations that we have.
So maybe just a final round of closing remarks, right? Like, so maybe we'll have time for a couple of sentences on your future-looking perspective on this entire research field and what it can do for the world. Justin, do you want to go first?
Yeah, let me have a quick briefing. So I think I have two keywords. So regarding the data analytics. So the first keyword is democratizing. So many people are still not aware the power and the sensitivity of leveraging causal techniques. And then another keyword is expert users versus non-expert users. So in recent years, a lot of the non-expert users still have the strong willingness to consume the data analysis tools, and how to provide the reasonable and friendly output, yet scientifically, to these users is still an opportunity. Thanks.
Daniel?
Yeah, kind of looping back to the beginning, I think there's lots of potential in how humans interact with AI systems in the real world for causal inference and causal modeling. And one thing that's been done in the past in this domain has been, experimenting with learning causal relationships in, for instance, physical models. Having an algorithm learn the physics, but what happens when we're trying to learn, for instance, social physics, where there's much less well-defined rules, and those rules can change depending on context and things like that. So that's what excites me. There's I think a lot of questions there about how we do that, but I think this is going to be something that's integral to building safe, embodied, situated intelligence, like self-driving vehicles, or many other things beyond that.
Completely agree. And Javier, you have the final word.
Yeah, this has been mentioned before, but I would say safety and transparency. I think these are key in the healthcare domain, to make sure that we can help with our algorithms, whether that's a helping a doctor to make a decision, or helping someone in a hospital about how the hospital should be organized. This is key for everything that we need to do.
Excellent. And with that, thank you all for joining us in this panel. Thanks, Javier, Daniel, Justin, for a very provocative view of the future and how causal ML can get us there. Thank you.